Welcome to AI Entanglement. I am Prem Talreja, the host of AI Entanglement and also the CEO of LunaGen, where we provide advice on technology and AI specifically. What is AI entanglement? It is the intertwining effect of artificial intelligence and humans. And this is the first time this has happened at such a scale and such a pace that it's worth understanding how the entanglement and intertwinement is taking place for the benefit of our work and our home productivity. Of course, there are concerns about AI entanglement, and I'm very optimistic about AI, artificial intelligence, because I think it has a lot to contribute to like previous revolutions or generations of technology have done. But there are concerns being raised in the industry because of the enormous amount of CPU, GPU power required for running the LLM. So there is a concern about how much power consumption and data centers will consume. So there's an energy issue impact of it. And then the other part of that is that AI technology, for the first time, LLMs are very non-deterministic. And so they are gobbling up a lot of information, but we are concerned about how that information gets presented, delivered, and could that cause misinterpretation for people. Of course, the wise people will know how to sort that out, but that's what the entanglement issues and concerns of AI are at the present time. So let's get right into it. My guest today is Dr. Sam Khose, and he is an amazing person who is a technical lead and the architect of his present company, CGAI. But I think his background is amazing in terms of his technical expertise, having worked with NASA and JPL in robotics and having, of course, a PhD degree. And so he's at the cutting edge of what is happening. And I think I would love to peek into his mind and see where he can shed some light on AI and all these things that are happening. But he's an amazing entrepreneur, thought leader. So, Sam, welcome to our podcast.
Yeah, thank you for having me. It's a pleasure.
Yeah, you're most welcome. So let's get into it, Sam. CGAI. I got to know a little bit more about it in talking to you earlier. I think it's very intriguing what you're doing with CGAI, and the name by itself does not convey anything. So I'd like you to please take a few minutes for the listeners to understand what is CGAI doing.
Yeah, definitely. So basically, we have a unique solution, which is a model agnostic cognitive control layer. It can plug to any LLM stacks and immediately govern, judge, repair, and verify the output. So basically, it's a middleware can sit between user and any application. And as a result, we have saved up to 70% on the token cost. We detect hallucination, 90% reduction in water consumption, and up to 70% reduction is in power consumption, and overall less pollution for the planet.
Wow, that's a lot to take in, but that is amazing because it does come. I'm glad that you brought all these points into one place together, because I want to just understand that you said something about a cognitive control layer, right? So this looks like a layer on top of layers, but it also looks like the primary layer, if I may say so. But it reminds me of something way back when we had talked about software-defined networks that came along. Is it something like that? Is an intelligent layer that, how would you relate that to SDN or software-defined intelligent layer, if I may say so?
Well, the software SDN was infrastructure to infrastructure,
right?
Versus we sit between infrastructures and applications. So let's say, or a technology, which we call it Alexis platform, Alexis to AI models is equal to what SDN was to networking hardware. That means a software-defined control plan that makes the underlying infrastructure interchangeable, governable, and cost optimized, if that makes sense.
Correct. Right. So it's actually quite a bigger play. It's groundbreaking, and it's actually quite impactful in terms of the overall industry where we are going. So let me ask you, as a cost reduction, what exactly are you saying and doing to reduce the cost?
Well, I think the current problem is everyone is struggling with, obviously, a year before it was a honeymoon of AI, and every company were spending their VC money. We were getting lots of tokens almost for free. You would pay $20 for subscription. And then what later happened with agentic AI, cloud, codex, all this different agentic AI, everyone started using it in a high scale. And it takes you a couple of minutes to just literally just reach a million tokens. So, and the current problem is you want a very high intelligent when you're using a top tier models, let's say right now today, Opus 4.7 or ChatGPT 5.5. And then you get used to, especially if you're doing something very complex. And then you run out of token. And the solution everyone is suggesting is let's change to cheaper model. But if you're mid developing your application, suddenly you're changing to another model which is much more smaller and probably doesn't have the high intelligence you get from the top model. How you can guarantee that you're getting the same result? So just changing to cheaper model by itself, it does not guarantee the result is going to be similar what you get from the top tier models. So my first education is basically medical science. So I always like either in robotics or AI, everything I do is pretty much bio-inspired. And human brain is very optimized. And the way that we solve a complex task. So that's what we're doing. So basically, we built this technology, this engine, which you have this governing inside your head. Inside our engine is very similar. So you talk to yourself, and sometimes maybe even if the task is too complex, you're going to ask for additional resources. And even if that doesn't help for a human to solve a problem, probably you know someone who's smarter, you just call them or just ask them to help or judge what you think. So we built the same system. So basically, we have the brain of the engine, which is trained to understand the complexity of the task. We have the student model, which is trained by very top tier models to understand how to solve the complex tasks. It's very similar. Like, let's say you bring a very smart intern to a company and say, I want you to shadow the CEO of the company for 1 year and see how he talks, how he answers questions, how he managed his task. And after 1 year, this smart intern can do majority of the tasks that CEO does, but you're still paying the price for an intern. And CEO now has so much time because someone else is there is doing his job. So that's a very similar principle for a student model. And then for the judge system, you can plug in any other models from any other LLMs to be the judge. And also you can have a fallback. So that means like whatever API you're using today, so it could still remain as your fallback. If something that is too complex, that engine thinks it should go right away to the original API, it will send it there. If it's something that can be solved internally, this whole cognitive layer that make this communication inside this engine between three models and how they basically give each other notes, how to repair, just sometimes says, I think you got it somehow. Yeah. So that's how it works.
No, okay. So, well, I like the way you described about the honeymoon, and I hope it's before the nightmare hits. You are addressing the cost issue, but you were describing the runaway cost concerns or shadow AI. People talk about that, and then what you talked about now was describing that you have an inference engine that is not just a router, but is actually intelligently acting like you described the human brain. And so I like the way the analogy you gave. I won't repeat that, but I think it was very well put together, that it's actually acting on your behalf and saying what's the most optimum way to get to the information you're looking for. But let me ask you this, that this is now an emerging problem. I mean, people are talking about it. The cost issue is there, and also the multiple LLM models are competing with each other in a way. So engineers are having to move back and forth, probably in manually or being told to. But let me ask you that in a way, this problem is so huge that the large model players would also be addressing it, right? So
yeah,
how would CGAI complement or advance that even further?
Yeah, so that's like even those very large models. So let's say if you're using Claude, you're using 4.7, and then you want to get cheaper model, you change to the model. Still, there is no intelligent routing engine between these two models to govern that. So that's the issue. So let's say in this case, you still can have your Cloud 4.7 as your fallback or even as your judge, but still using the other models, which is much more cheaper as your student model or even replace it with judge. So that it looks like you have the country, but there is nobody to govern that. So, and nothing is going to work out because there would be a chaos. Versus this engine is where it does a very couple of important tasks. First is governing that, and second is repairing. Repair is very important because sometimes the way you can get best out of a very small or cheap models is to mentor them. So what we're doing basically, we're saying to that small model how to get it right by mentoring it, not producing the output, because producing output is very expensive. So input is much cheaper. Like let's say if you're paying for $2 for 1 million output, you're paying $25 for 1 million. For 1 million input, $2. You pay $25 for 1 million output.
Outputs, yeah.
But you can say a couple of words to a cheap model. I think you should do this, and then you're going to get the answer. That's very much like the way human they find answer to questions.
Yes, yes. They find the shortcuts based on their own experience and thing. So this ends up being a impact on a cost for sure. So how does that happen? How does the cost come down? I mean, I can almost surmise, but cost and of course then that relates to the energy consumption and all that. And you mentioned some numbers. Can you repeat those again? I didn't quite grasp them.
Yeah, so basically the whole engine we built, it can run on under 46 gigabyte of VRAM, which is like almost, it could be one consumer grade GPU. Or
Yep.
if you have like A6000.
It could run on your local
Yeah,
laptop.
yeah, or I'm having a A6000 Blackwell, which is 96 gigabyte. You can run two of this engine
Right.
locally on your organization. Versus if you want to run this on a data center, like for a model like 1.5 trillion models, which most of this large AI models, even they are larger than that. So you're going to burn thousands of dollars per hour versus like cost of running 24/7 one A6000 Pro Blackwell. It's about $60 just electricity bill.
Gotcha.
So, and in terms of those savings, so we basically benchmark against the base, and we calculated based on how much token we were generating comparing to a base model and how much it could be saved. Let's say if you're running 5,000 prompts through, let's say Opus or ChatGPT 5.4, and then you run the same 5,000 prompts into our engine. So, and how many of that 5,000 prompt, when it went through our engine, only 30% of 5,000 prompts use the fallback, means like use whatever API client was using. It was able to solve 70% of the problems internally inside the engine without a need of kick in a larger model.
Gotcha. Well, so I can understand the idea of a stage system. The smaller model, then it learns or it figures out where else to go for more expert information from a judge. So this staged condition sort of beats a single shot model where you just throw everything at the large model is what you're saying. So how will this impact the AI enterprise systems, going forward with CGA?
Well, like a couple of years ago, you were just getting answer from models. Whatever was based on transformers, they would just predict the next token, and you would get mostly like way more lower quality response. And then majority of the LLMs, they shift their models to the reasoning model, which is like it has more token context window and it has like more awareness when they generate response. So we added another layers to that, which is like this stage reasoning. So basically you're going through, let's say if AI generate response and the final response still says, let me judge myself, but I don't want to self-govern myself. Let me bring someone from outside to judge my answer. And then before I produce the response. And if that outsider says to you, like, I think you didn't get it right. I think the answer might be this. And then you're going and regenerating that answer. So it's a little bit additional reasoning on top of all the reasoning models. So, and the beauty of that is you can plug in any models you want and without losing quality. So obviously, if you're using like a very low quality small model, so you're going to have a higher fallback. That means instead of you're saving 70%, you might save only 30% because you choose a very small model is not capable of doing your task. But I don't think even our clients is going to be so crazy about this cost saving. I think knowing that you're getting a response that is well taught, like the way human think, because everything we built over past 30, 40 years on, or even at the time of internet and online world, like is built to just work for human.
Yes.
And still, if you want to produce respond with LLM or using AI in agentic form, you still need to have that human-centered approach. That's how human they think and how their human address the problem. But I think the bigger issue we're solving that is currently doesn't exist is by the time, let's say your organization keep using this engine, every time you have something that is complex and goes through this stage processing to solve the problem or send it to the fallback, you started generating a very valuable data set for yourself, which you can download it or we can train that for you. Now you have a customized LLM that is very specific to your own case in your business.
Right, right.
And that's a valuable. It's going to sit on top of any other LLMs, and that would handle majority of your tasks. Let's say if you're JP Morgan, probably, and using this engine for your customer service, probably most of the people contact you, they're going to ask about the same question. Either they have an issue with their bank account or something missing, and the system is very intelligent, start learning, self-learning from your business, and that stays on your dashboard. Whenever is the time, you can decide to train your own low-rank adaptation model on top of the large model to sit, and that become very valuable for you.
Gotcha. So in that sense, let me ask you that, should I be worried about latency? Because in some projects or some instances, let's say it's drones or IoT or whether it is real time, one concerns about latency. Does this staging method produce any latency or significant latency?
No, we're currently our latency is 1.6 millisecond, which is like, it's impossible. We can produce 4,800 token on 96 gigabyte GPU. So there is no way any human can read anything that fast. 4,800 token is a lot per second. So the latency, I don't think my background was all about edge computing and robotics and real time processing
Robotics,
of
yeah.
visions and autonomy, and always latency was the biggest challenge of my life I was trying to solve. So I'm very mindful of that when it comes to solving the latency problem. But I think sometimes, like I believe, like let's say like you don't take a F1 Formula car to go and buy your grocery. That's a problem right now people are doing. Even like I'm sitting with people, I say like, why you're using this expensive model? Just you're writing an email.
Yeah.
I never use that expensive model to do such a small task. So that task can be done in a model that it can run on a CPU even.
Yes.
So I personally use very expensive models only for a very complex like research, like if something is very complicated. So I think for most of the people, it's everything we see on the top models is overkill. You really don't need that.
Right. And I think we're coming from that stage where we have gotten interested in the shiny object, and then the overkill factor is coming in, which is now hitting our pocketbooks as well. So I think your point is well taken. So I'm going to now switch to the second part of your product, which correlates to this part, but I would like you to find the correlation better, is about trust. Because, trust is fundamental in our business, in everything we do. And trust has become a bigger issue for some reason with artificial intelligence and the LLMs, as because of this sort of vocabulary that has come into our life called hallucination or undeterministic or less predictive. So it's funny how trust has become a bigger issue for CFOs, for CEOs, and even for governance and all those aspects. So you're addressing trust as well. So it's a powerful word. Can you walk us through how CGAI detects and addresses trust?
Yeah, so during that process, we built this judge and repair system inside the engine. I realized if I branch out from this part of the engine and add additional layers of verification, I can help to detect hallucination, fabrications, fact fabrications against even evidence document. Let's say, like, for example, like myself, a couple of years ago, I tried to prepare all of my accounting for my accountant through
Yeah.
AI. And last minute, before everything was done, I just said, let me just manually like audit that. And then going through the first couple of lines, I see everything is wrong. And AI was so, at that time with ChatGPT, was so confident, assuring me 100 times I asked that everything is based on fact and it's based on the documents, bank statements, and everything. At that time, I said, like, this is insane, because right now, a couple of years later, we see, like, I see people, they really believe what AI says to them, and now lots of large models, they even fabricate facts to use it as a reference. So we built this verification system with 7 layers of verification, including web search, but also web search is from reputable places. And it's based on all these different layers, semantic judgment and all different things, even based on what LLM thinks is right or not. So that it produces a confidence value. And based on what's that value, you know how much confidence you have in terms of if this request you ask, if it's pass or it's a negative. And if it's negative, so it's going to escalate it for human review. So instead of, like, let's say a large company, an enterprise company, most of them, they can't use AI. They use AI for, I don't know, like writing their codes and all stuff. But you can't put an AI, a team of agentic AI to run your business, because they can hallucinate. Like we had so many cases, like recently there was a company, their AI was producing a wrong information about their business, and they shift all of their investment toward those information because they didn't know these are hallucinated. And after a couple of months, they find out like this is all wrong data.
Wow.
So we're addressing that, and I think trust is even bigger than cost, because you can't use something that you don't trust. So it's look like becoming friend with someone you don't trust.
There exactly. And putting it in the business terms, I would say that one is trust is immeasurable. So, depending on the circumstances, what do you pay for trust? Okay, that's an immeasurable factor, unmeasurable. But the other thing is that the powers to be in a company, if they don't have trust, they will hold projects back in spite of the benefits they can see, but they will not let the projects go forward. Is that your experience, or is what you're addressing?
Yeah, so even our engine, let's say we're generating a response and we save 70% cost for the same prompt you would get from top tier. Still, we're comparing this response, this output, against another output from another large model. Still, from both of this response cannot be verified. Maybe both of them are hallucinating. So that's why the verification system, that after the response is generated, now you can verify that. And again, there is a self-learning mechanism is involved. So let's say if your business catching the same type of hallucination, so I think after a few months, you can now train your own hallucination detector, because it's very unique to your business, because most of the mistake and hallucination comes for your client, for your customers, are very similar.
Yeah, I agree with you. And I think it's like a supervisor sitting on top of your trust engine, But so I've covered cost, I've covered trust, and I think this podcast can go on for a longer time. But I want to now ask you a couple of questions on the broader experience you have with AI. That what has surprised you most about AI, and what can you share with entrepreneurs and others listening to this? That what has most surprised you, or what how has that impacted your own company in terms of development,
You know,
speed?
if you've been around like previously, let's say
Yeah.
when I started, if you had an issue like your code wouldn't run correctly, you know, like we had couple of places we have to go and post whatever error we would get from our terminal or what code we were running. I remember like before someone just give you an answer and help you, you would get bullied for like couple of days. Like these people like more senior like programmers, they would comment so mean to you. You know, oh, are
Yeah.
you dumb? You don't know how to write this, you know, like
Yeah. Right.
and now I'm thinking like with AI, like I just like I haven't coded for 2 years now. I literally haven't coded for 2 years. I don't need it.
Yeah.
It's much more efficient, it's much more faster, and all I have to do is just read it and supervise the process and make sure like they don't get ahead of themselves.
Yeah.
And also like for specific my use case, like I couldn't make this product if it wasn't because of AI. I would need at least like 10 researchers. I would need at least a team of 20, 30 people to just build the engine, to deploy that, to make the dashboards for clients, for admin, all those things. And now with the power of AI, literally like I didn't have the expertise to deploy something on it wasn't like DevOps. It would never been like my expertise like
Mm.
but I knew how I can just like use GCP or
Yeah.
AWS or Azure
Mm.
to set up my servers manually, and then how can I remotely connect to my servers. That's how much I needed to know.
Yeah.
The rest could be by agentic AIs like the 24/7. I think it's really a powerful tool, and I think the part that I'm extremely excited is about the application of AI in medical science. So I'm so grateful. Like we always tell people, if try not to die next 10 years, because if we all survive another 10 years, I know there's cure for so many disease. Probably, you know, probably we have cure for cancer. Probably you have majority of disease can be like gone, so we will live a longer life.
That's your medical science PhD. So let me ask you that again, I touched on it earlier, but I will touch back on it. Cost reduction and trust building are two huge pillars, okay, in the industry. So as a startup, which you are, hopefully one day you will be a category building, very successful company. But as a trust building, as a CEO, how do you balance the pressures from competitors and your own internal balancing act between resources and in engineering and business development? If you can touch on that, it would be great to
Yeah,
hear
I
from an
think
entrepreneur.
I think lots of people like they're choosing more attractive product. So we choose something that is really boring. It's not attractive at all, but it solves a very big problem.
Mm.
So I think if you know what problem you're solving, and this problem is so huge, like there are lots of opportunities for many companies to provide the same services, because it's impossible for one company to provide all of these
Sure.
services even.
Mhm.
So the demand is really high.
Yeah.
And I think we built this with the philosophy that we don't want to compete with anyone. So we want to complement every
Yeah.
technology out there to be able to benefit from that, because I believe in the power of like there's so many like open source technology throughout my career I use, and they help me to build my
Mm.
reputation and my career.
Yeah.
And this is one of those things that we can help other companies to just move forward and be more optimized. And imagine like this year is all about agentic AI.
Yeah.
It's impossible you give couple of $100,000 worth of money to a couple of agents and say, listen, go do this for me. You need to have some governing system in place.
Yep.
You need to build trust. You need to be able to audit every single responses generated by those bots. So
Yeah.
that's very important.
Yeah. Well, and I think what you're saying is right up and down the line from a small, medium business to the large enterprises, this exposure is going to be there. The small companies will face the runaway costs, and eventually they'll have their reputation disrupted by lack of trust, or the large enterprises are holding back projects or not able to fully capitalize on the projects that are in hand. So I get it. And I think I like your point about the fact that this is a collaborative effort in the industry. In other words, the way I see it, correct me if I'm wrong, is that you're sitting at an agnostic, neutral position and saying, I don't have a preference or one way or the other. All I'm trying to do is optimize your cost and give you the best trust. And you're agnostic to the LLM companies. So they can do what they want, but they would not be as agnostic as we would be at CGAI or your CGAI would be. Is that a fair way to
Yeah,
put it?
that's correct. Like we're
Yeah.
very agnostic in terms of hardware, in terms
Mm,
of
yeah.
any LLMs can plug in.
Okay, well, we are at the end, but let me just ask you, for future leaders, what advice can you share to navigate through this age of AI? I think you touched on it, but any encouraging words or words of where failures can happen too rapidly if you don't
Yeah,
think about it?
I would say like the good thing about AI is you fail so fast. You have a chance to keep repeating instead of like before you used to spend 6, 7 months to have a product
Yeah.
ready
Yeah.
for demo. You can now have that product ready in one day and you can test it, you can get feedback and you can fail next day and then repeat this process. So failing so fast is really a blessing because you learn how to pivot and change your direction until you find where is the right place for every individual.
Right,
And
right.
I
And yeah, Sam,
and
I
I
think well
think
said. And I think one of the areas that I would just plug in is that fail fast. You can fail faster, if you will, because you can iterate. But I don't believe AI by itself is going to reduce the time to market in terms of the go to market, the customer engagement, customer acquisition. These things are far more time consuming and unrelated to AI. But I think that this is an area where we do some advisory work, but I don't want to harp on it. But I think you made a very good point about just about the failing fast. So again, Sam, thank you very much. This is not the last time we're going to do a podcast with you because there's so much to unravel here. But thank you very much.
thank you for